Hello students, good evening everyone. I hope you are getting the voice clearly. Just drop a message if you have any um, issues related to voice or screen blurred kind of. If your screen is blurred, you maybe not that good, so try to check that also. Maybe not that good, so try to check that also. Right. So laws of motion. Today's concept will say this guys. So we're supposed to discuss as per connected bodies problems. Connected bodies problems. Let me check once whether the streaming is proper or not. Just a minute. I want to check whether the network is good or not first. I think the network still at my end the network is little slow. You are offline. Guys, still I am getting the network error. Still I am getting the network error. You are offline. Still I am getting the network error. Right guys. You can now pin a message to top of your live. Okay, fine. Live chats. Right guys, let me start with. So it's already 10 minutes over. Briefly, we'll discuss in this session about connected body problems in laws of motion. Connected body problems. Connected body problems. So what kind of problems? You need to have an idea of some basics like common forces in mechanics, specifically tension and normal reaction, etc. Right. So let us start with one small system. We can say Atwood's machine. and some related systems. Let us start with Atwood's machine. Atwood's machine is nothing but Atwood's machine, right? So it consists of a pulley. It consists of a pulley which will be attached to a rigid support, and on the be passing over to both the ends of this pulley two blocks of masses M1 and M2. To the other end another block of mass M2 will be connected like this as shown in figure. This system is called Atwood's machine. Now what kinds of questions will be asked based on this system? This is a simple system, guys. Okay, if you understand this, then we can apply the same phenomena to the extended systems, right? Here, so here first you have to mark the forces acting on every part of the system. On M1 block, the force M1G acts downwards, and on M2 block M2G acts downwards, right? And at the same time here, and the string, usually in this kind of systems, as per our discussions, you have to remember that the string will be considered as an ideal string. Ideal string means the property of ideal strings should be massless. This should be a massless string, and it also should possess a property called inextensible. The string should be massless and it should be inextensible. Inextensible means if a force is acting downwards, because of this force the string shouldn't extend, it should be rigid. So tension at M1 side, if you observe, a tension T acts away from this point of contact, and near M2, if you observe, here also the tension T acts away from the point of contact. Now here at this point of contact, of course T acts downwards, that is away from the point of contact. Here also away from the point of contact. Whenever we deal with this kind of questions, you will be asked to find two parameters, usually two parameters. One is acceleration of the system, another one is tension developed in the system. See, if M2 is greater than M1, M2 is greater, then this block will move down, and when it is moving down, M1 block will be pulled up. So it is moving down because of some external force, so you can say net force, so you can say it is moving down with an acceleration A. As it is moving down with an acceleration A, this will be moved up or pulled up with an acceleration A. Right? So both the blocks will move with the same acceleration. One is M2 is moving down, M1 is moving up. These points you have to mark carefully and understand carefully. Then to find acceleration and tension, to find acceleration A and tension T, acceleration A and tension T, what we have to do? So you have to draw the free body diagram of the blocks M1 and M2, and then you have to write equations of motion, and then we have to solve. First, free body diagram, FBD stands for free body diagram of M1. So what is free body diagram? You should remember, free body diagram is a diagram of the forces acting on a particular part of the system. We are considering M1 for M1. So mark M1 as a point object with mass M1 here. Now M1G is acting down and T is acting up on this. M1G is acting downward, and now after drawing free body diagram, you have to write equation of motion. Equation of motion says that net force on the part of the system is equal to its mass times acceleration. What is that? Are following. So free body diagram means representation of all forces with directions on the body. On M2, M2G is acting downwards. M2G in the diagram, if you observe, is acting downwards. T is acting upwards. These are the two forces acting on it. That's it. And as a result, it is moving down with an acceleration A. Now the equation of motion says net force is equal to its mass times acceleration. These two forces gives you net force, that is m2g minus t is equal to m2a. Let us take this as equation. Equation 1 is t minus m1g equal to m1a. So equation 2 is t m2g minus t equal to m2a. On simplifying this, we will get acceleration of the system. What is that simplification? We can add or subtract. Let us consider here to find a and m2a. Now let us add them. If we are adding, so minus t plus t gets cancelled and nothing else will gets cancelled. Now if you add these, here minus m1g plus m2g on left hand side, so we can write it as g is common, m2 minus m1 into g plus m2a. Again a is common here, you can write m1 plus m2 into a. So therefore we want acceleration a. So a is equal to m2 minus, what is this, m2 minus m1 into g by m1 plus m2, or you can say m1 minus m2 by m1 plus m2 into g. This gives the acceleration of the system. This here I would like to give you one shortcut, guys. I would like to give you one shortcut to find the acceleration. So if you again recollect back here, the Atwood's machine, this is the Atwood's machine, right? Here m1 and here m2 is there. So m2g is acting here and m1 m2g, yeah? m1g is acting here. So as a result, it is moving down with acceleration A, this is moving up with an acceleration A. So this we can take it as identical to a string attached here. Just you hold these two masses and take it horizontally in horizontal position. Then we can say m2 is here, 1 is here. So m2g is here and m1g is in opposite direction. As a result, it is moving this direction, then acceleration A, and this also moving this direction. So in opposite direction to m1g, it is moving with an acceleration. It means motion is towards right. So acceleration. So the shortcut I am giving you guys here. Shortcut. The shortcut is acceleration A of this system, of this kind of systems, connected body systems, guys, okay, is equal to net force, net external force, you can say net force by total mass. Are you getting this? M total mass of the system. Here this system is having two masses. So net force, as it is moving towards the right, m1g is towards right. Sorry, this is m2g, guys. m2g is to the right, m1g is to the left. What is difference between these two forces? That is m2g minus m1g. We can write it as m2g minus m1g by total mass is what? Sum of these two masses, m1 plus m2, m1 plus m2. As g is common, you can write it as m2 minus m1 into g by m1 plus m2. This you can take it as a shortcut. Net force by total mass, acceleration of the system. So no need to do no need to draw free body diagrams and write equations of motion and solve them directly. By using this shortcut, you can find acceleration. While doing numericals, you can remember this, guys, okay. Next, how to find acceleration? Let us go up. See here, if you observe this equation 1, a plus m1g, so it is equal to m1 into m2 minus m1 by m1 plus m2 plus m1g plus m1g. Oh, here also g will be there. So now if you observe, actually here m1 is common. You can, if you take it out, you can write a plus g. take this m1 out. So you can take here m1g out. So we will get m2 minus m1 by m1 plus m2 plus m1g out. So 1 is there. Now on simplifying this further, we get m1g into m2 minus m1 plus m2 by m1 plus m2 Here minus m1 plus m1 gets cancelled. m2 plus m2 will be remaining there. So m2 plus m2 gives you 2m2. That 2m2 into m1 will give you 2m1 m2 into g by m1 plus m2. This is the tensional force or tension developed in the string. You can take this as equation 4. So this is how we can find the acceleration of upwards motion and tension T developed in the string of an upwards motion. So copy it down, copy the points. Let me check any messages are there in the live chat. I think there are no messages. Maybe whenever blurred means my internet connection is not proper. So I will get it as a little blurred. So try to change the settings. Guys. Then you'll get little more clearly. Connected body problems, right? So I hope this is clear for you. So if you need, you can go back, scroll it back and refer it and try to note down the points. Don't simply listen and leave it off. Try to write down the points on your notebook. Yeah, I'm just the streaming is clear or not. There is some delay in my another system. The net is slow, so I may be getting not be getting little. Let us start with another system, another connected body problem systems. Let us say, now you can take it in question form. So same, write down as a question, find acceleration A, and you can say find acceleration, and this is a table, you can see, okay. And on this surface there is a block of mass, and here at this corner a pulley is connected, and to this block M2 a string is connected. It is passing over the pulley. That to the other end a block of mass M1 is connected. Now obviously, as here on this it is mentioned that it is moving down with acceleration A, and the tension T is acting over here, and the tension always acts away from the point of contact. So here also away from the point of contact it is acting. So this block is moving with an acceleration to the right. M2 is moving to the right, M1 is moving down. So this is the figure. Usually some cases it will be mentioned that M1 is greater than M2. This kind of conditions also will be given. As here it is moving down. So how to find acceleration of this system and tension developed in the string? Same procedure which we have used in the previous case we have to apply here. What is that? Is you have to draw free body diagrams of M1 and M2 separately, and you have to write equations of motion for M1 and M2 separately and solve them. You will get acceleration, and substitute that acceleration in any one of the system, you get tension. and that is one way. Another way to find acceleration, you have to use that shortcut. What is that shortcut? The shortcut, it says net force on the system. Acceleration is equal to net force by total mass. Net force. See here, this if you can write it as all other forces. Here as M1 is just hanging on M1, M1G will act vertically downwards. And of course on M2, because it is on a surface, M2G act downwards and the normal reaction acts upwards. There is no motion in vertical direction. They will balances. So there is no motion in vertical direction. It is moving horizontally to the right. So now on M2. First, you see here. Yeah, you can say. Let us take in terms of free body diagram procedure method only. Free body diagram of M2 here, because on M2 only force acting is tension. Okay, on M1 two force acting. So M2 if you draw here, this is M2, and this only tension is acting to the right as a tensional force here is acting to the right, tensional force. As a result, it is moving the acceleration A to the right. Now if you draw write free body diagram, net force is equal to mass times acceleration. Net force is only one single force, that is T, is equal to mass times acceleration, it is equal to M2 into A. You can take this as equation 1. Now just beside to the side of it, draw free body diagram of M1 and write equation. Free body diagram of M1 FBD downward and T vertically upward, and as a result it is moving down with an acceleration A. Now the equation of motion is net force equal to mass times acceleration. Net force here is the downward equal to M2A. Just substitute here, then you will get M1G minus M2A is equal to M1A. Okay, so you have to take this as equation 2. From 1 and 2 you can say 1 and 2 gives, or substitute 1 and 2, it will give you this one. So now you send minus M2A to the right, it becomes M1A plus A out common, then you can write M1G is equal to M1 plus M2 into A. So it gives A is equal to M1G by M1 plus M2. This gives acceleration. Right? Now by using that shortcut, what is that shortcut? This system can be taken as identical to right, this is a string M1 here, and this M1G is acting in this direction, tension T is acting in this direction. Total mass, net force is M1G, total mass is M1 plus M2, directly can get this acceleration from this. What is that? This is a shortcut notation. Because this, if you take it as identical to this way, you will get this one. But as per the procedure box guys, just to refer. Now to find acceleration, tension as from equation 1 directly, equation 1 implies M2A, A is this, equation 3, substitute here you get M2 into M1G by M1 plus M2. So you can write M2 into G by M1 plus M2 will be the tension developed in the string. That's it. You can take it as equation 4. This is how you can find the acceleration and the tension of a system shown in figure. This kind of. Okay. So some equations are hiding behind my, what is that, photo display. Okay, just now I have realized that, that's why just I am moving. Some of you can drop a message guys, so that I can realize those mistakes. Some of you can just drop messages if it is hiding behind the display video or photo, whatever it is. Okay, or if voice is not clear, or if the screen is blurred. Now the screen is clear. The screen clarity depends on my network buffering. Okay, if your network is very low, you will get the screen as blurred one. If your network is good, it can be very good. For that you have to change the settings of that particular video. Okay, I'll give you. Let's note down. Next question is same. Find acceleration and tension developed in the system. Like simple systems I will give. Then you can go through the accelerated ones. I don't want to go little quickly or hurriedly. I want every one of you to listen, write down and follow carefully. Tension developed in the string. Find acceleration of the system. Means block will be acceleration of the system. Find acceleration of the system and tension T. I am just simply giving the symbols here. We have to write in full form. Okay, tension T developed in the string. Develop in the figure. The figure is this. Now we are having a system in which we are having I am giving the system here on the right side. Will move down, okay, you can say, because of the forces on these blocks. M2 will move down, M1 will move up the incline, and as a result, okay, you can say it will be moving some acceleration. How to find that? So let us try to redraw this diagram. This is the given system. That's it. You have to redraw by representing the forces. Redraw this little bigger one. This is the system. This is the system. Mark this is theta. This is M1, and here is the pulley. The string is passing over, is connected to this and passing over the pulley. Here M2 is connected, and because M2 is hanging here, on M2G is acting vertically downwards, and a tension T is acting away from this point of contact here. As we will consider this pulley is a frictionless pulley or ideal pulley. String is also ideal, so tension will be everywhere same, and at this point of contact also same tension T acts. Okay, right. Now this is M1, M2G is acting external force acting on M2. Then what about on M1? On M1, M1G acts vertically downwards. M1G by symmetry, you can say the normal reaction force. This is normal. The force which is normal to the surface acts in this direction, and by symmetry, this will be theta. So here, inclined surface, down the inclined surface. Okay. Right. This is moving down with an acceleration A, and it is moving with an acceleration A upwards. So this entire system is moving like this. Using shortcut, acceleration A is equal to net force by total mass. Net force. To find net force, you have to take this is identical to this is this or this, either we can take is identical to a string is there, M2 is here, and M1 is here. And what are the external forces acting on M2? M2G is acting here on M1. M2G. This is M1G sin theta. So G is common, so you can write M2 minus M1 sin theta into G by total mass is M1 plus M2. That's it. This gives the acceleration by shortcut. This gives the acceleration. Oh, again it is this is blocking the picture. Pull down. Okay. Now, by using the actual procedure, conventional procedure, you can draw free body diagrams, and hence you can substitute, simplify and get it. Once you are thorough with this, we can using the shortcut. and you directly can write one equation of motion for any one of the block, and in that substitute for A, and then we'll get tension. So let us take for M2 free body diagram an equation of motion that is moving down. M2G minus T is equal to M2A. You want T, you bring this T minus T this side, you'll get plus T, it becomes plus T. T is equal to, and bring M2A here, and you can write M2G minus M2A. M2 is common, so you can write M2 into G minus A is M2 minus M1 sin theta. We have to write this in the proper straight line like that. Yeah, because of the board. Yeah, see M2 into G M1 sin theta into G by M1 plus M2 is A. So again here G is common, take it out here, so it becomes M1 plus M2, and multiply with this minus sign, we get minus M2 minus of minus plus M2 sin theta. G has gone out by M1 plus M2. Now minus M2 plus M2 cancel, well, you get M1 plus this, right? So what will be the tension? What will be the tension? So you can say this is equal to, what is this, M1 plus M2 sin theta. If you send this inside, we keep G out, you can write it as M1 plus M2 sin theta into M2G by M1 plus M2. As the calculations part is clear, did we do any mistakes here? This is M1 plus M2 minus M2 plus M1 sin theta. This is M1 sin theta, yes. Yeah, here it is not M2, M1 sin theta. Yeah. This is M1. M1 sin theta. So M1 plus M1 sin theta. This is not M2, guys. This is M1. So M1 is common. Take this out. Take this out by M1 plus M2. This gives the tension. Cross check the simplifications part. This gives the tension of this kind of system. What is this system? This is the system. Here we have taken the condition as M2 greater than M1. So the system is moving down. If M1 is greater, then the body should, the block should move down the inclined surface. Then the scenario will be different. Okay, we have to be careful about the conditions also given in the question. Whereas if you have, I will give you just one more this kind of systems of connected body problems. There are so many different kinds of connected body problems will come. So these are a few simple cases. I will give you one more case, then I will wind up. We can work out a few more cases in the later session. Right. Next case. You can take same. Find A and T. Find A and T. In figure, just let me draw the here. So this is this is the system given here. This is the system given here. This is theta 1, this is theta 2, in some case both you can take the theta only also. Another block of mass M2 is connected. Now let us consider here again, depending on which is the larger mass, M2 is greater than M1. So this is moving in this direction, and so this is moving in this direction up with an acceleration A. This acceleration, and there is the same string, so tension will be the same everywhere, T and T. This is the figure. So usually this also will not be mentioned in the diagram, so you have to understand. In this case, again you have to redraw the diagram and you have to mention all the forces. Okay, you have to redraw the diagram, a little bigger one. So you should be able to practice all this properly. Then only you will get acquainted or comfortable with this kind of circular diagrams and simplifications. So let us take as it is the same diagram only. You have to redraw, guys. Okay. Now let us say here M1G is acting downwards and normal reaction is acting in this direction. For the first one, N1 you can take, and by symmetry this will be theta, and this will be M1G cos theta, and here we will get M1G sin theta. So take step by step, then only you will understand. Don't wait till the completion, then the entire diagram will look so clumsy. You know what? By symmetry, N2 normal reaction acts in the and this in upward direction, and this will be theta. Here we will get M2G cos theta, and there is no vertical motion, there will be an equilibrium, and here we will get M2G sin theta. As M2 is greater, so let us say M2G sin theta is dominating T, so it is moving in this direction, and this is M1 is moving in upward direction. It is moving down the inclined plane. Now again I am telling you have to draw these forces step by step. After complete representation of all these forces, if you look at this diagram, it looks more clumsy. Do step by step. Go back and try to draw the diagram step by step and try to understand every point. Now, so by shortcut, try to find acceleration. By shortcut, M1G sin theta. So, but it is because it is given the condition M2 is greater. This is background noise. Okay, Nana. So try to reduce background noise. Just a minute. Yes. I think now it is clear, guys. I'm not sure whether the previous part okay. You should have mentioned earlier. Now only I have received this message from Meena Kumari and Hitesh. Thank you, Nana. Thank you, Hitesh, and thank you, Nana. Thank you, Meena Kumari. Yes, right. Yeah. Now let us go ahead with this. By using this shortcut formula, acceleration A is equal to of this system. Acceleration A is equal to net force. Net force by total mass. Understand this properly, guys. Let me write little properly. A is equal to net force by upward direction force will be dominating one. So, and another force M1G sin theta is acting to the left. Difference between these two forces will be net force. That is M2G sin theta minus M1G sin theta. If both angles thetas are same, then sin theta can be taken out. Otherwise, if this is theta 1, this is theta 2, then you have to take it as M2G sin theta 2 and M1G sin theta 1, like that you have to take. That will be the total acceleration. Next, to find the tension, write the free of motion directly. If you are acquainted by now, if you are comfortable by now, you can directly write the equation of motion, guys. But I will draw a free body diagram and write equation of motion for any one of the body. Let us say for M1, free body diagram of M1. So here M1 is on the inclined surface. You can draw the inclined surface like this, or here this is M1 as a point object, and this T is acting up, and downward we have M1G sin theta, but it is moving up with an acceleration A. That means the upward force is dominating the downward force. Now equation of motion is given by dominating force is T, upward force. So T minus downward force is M1G sin theta is equal to mass times acceleration M1A. In this you have to substitute acceleration A. That what is that? Here you can take g sin theta out, m2 minus m1 by m1 plus m2 into g sin theta. This can also write it as m2 minus that. In this expression you can take it as equation 1, this equation of motion as 2. Okay, now let us substitute that A from equation 1 in 2. Yes, so we'll get T is equal to m1A plus m1g sin theta. Now substitute the value of A. What you will get? A is, it is equal to m1 into m2 minus m1 by m1 plus m2 into g sin theta is plus m1 g sin theta is the next term. Now here if you observe, this m1 g sin theta is common in both terms. Take it out and simplify. So you get this is equal to 2 minus m1 by m1 plus m2, here also m2 plus 1. Why 1? We are taking m1g sin theta out into m1g sin theta. So this in turn gives, it is equal to m2 minus m1 plus m1 minus m2. So minus m1 plus m1 cancel, you get m2 plus m2 is 2m2. Directly I am doing, guys, but you have to practice this properly. So 2, what is that? m2 plus m2, 2m2 into m1. So you can write directly as 2 m1 m2 g sin theta by m1 plus m2. So therefore I'm writing here, again it may be blocking by the video portion in the screen. So here, right, so go through again every step by step. I hope now it is the screen is also clear. Now the internet is also very stabilized. I think earlier this much of stability was not there. Now it is very stable. Now it is very stable. I hope the voice is clear. Sir, your video again hides the equation. Yes, Nana. I think that's why just I have observed and I have just shifted it a little bit. Right, guys, these are few connected body systems. So there are few more simple cases, but very important cases are there. Some of the questions have asked in previous years also. Just let me give you one more, then I will wind up. Let us see here another simple case of connected body problems. There is a smooth surface. Smooth surface means the coefficient of friction is 0. On this surface, external force is acting as. This is the only external force acting. Now, what is the acceleration of the system and tension developed in the string is the question. So simply, what is developed? Where you have to get the tension, that you have to understand properly. You have to redraw this properly. Redraw this and mention where T comes into picture. So let's say this is the surface, here m1 and here comes m2. This is the string connecting and this is F acting on the result. We have to say this block and this block, both blocks are moving with an acceleration A to the right. That is what we have to understand, because this is the net force. Now tension develops in the string, here away from the contact, here also away from the contact, because this is the same string, inextensible and ideal, same tension and develop everywhere, right? Now as it is moving to the right with an acceleration, and what is T you have to find. Now by using the same logic, what is that shortcut form, you have to say acceleration A is equal to net force by total mass. So net force, here you can take m1g and m2g also downwards, but normal reactions will act upwards. As there is no motion in vertical direction, they will balance us, so it will be in vertical direction, so there is the vertical forces will cancel out. Though, so M1G and M2G will not be considered as net forces in this case. The horizontal force, because it is moving on horizontal direction, horizontal force only you have to consider. So the net force is F only. Total mass is M1 plus M2. To find acceleration, tension. Now you draw a free body diagram of any one body. Specifically, draw the free body diagram of the body on which only tension is acting. On M2, F is acting to the right, T is acting to the left. On M1, only T is acting. So draw free body diagram of M1. Free body diagram of M1. Free body diagram of the body on which only tension acts. That is M1. So you can say this is M1. T is acting to the right, so it is moving to the right with an acceleration here. Now equation of motion gives net force is equal to mass times acceleration. So that is T is equal to M1 A. Already A we have got here. You can take it as equation 1. So from this you can say it is equal to M1 into A is F by M1 plus M2. So M1 F by M1 plus M2 will be the tension developed in the string. Take it down. So we have got, you can take it as equation 2. This is equation 1. This is how you will get what you call acceleration and tension. Acceleration of the system and tension developed in the string. So this is another simple case of two body connected problem, two connected bodies on a horizontal surface. Three bodies also you can. I am giving you a hint. You guys can try it. You guys can try it. Another question. See, there is a horizontal surface, smooth surface. Smooth surface means coefficient of friction is 0. Here you have blocks M1, M2, and another block M3 is there, right? And these are connected by a string, these are connected by another string. M2 and M3 are connected by another string. Now on this system, on M3 the force is acting. As a result, this and this, every body is moving with same acceleration to the right. So what is this acceleration in terms of M1, M2, M3 will be given, F will be given. In terms of these are known quantities. In terms of these known quantities, what is A? In terms of these known quantities, what is tension? So here you have to say that string between M1 and M2 will develop a tension. But the tension here away from the contact, here also in this string also there will be a tension away from the point of contact, but these two are different strings, so tensions will be different. Let us say this is the first one, so tension here is T1. This is, now draw free body diagrams. Directly acceleration you can find anyway, but to find tension you have to write equations of motions surely. Okay, now let us try to draw free body diagram and equations of motion. So without any confusions you can do properly. Free body diagram of M1 here, then equation of motion. Free body diagram of M2 here and equation of motion. Okay, we blocked. So let me write the free body diagram here little above. Free body diagram of M3, then equation of motion you can say. M1, mark this. Mark M1. On this only tension T1 is acting. As a result, it is moving with an acceleration to the right. So equation of motion is T1 is equal to net force equal to mass acceleration. Net force is only T1. T1 is equal to M1A. Equation 1. For M2, mark M2. Forces here is T2 to the right, T1 to the left. So it is moving with an acceleration here to the right. So equation of motion is, as it is moving to the right, rightward force is dominating. So you can take it as, so you can take this as T2 minus T1 is equal to mass times acceleration, M2A, equation 2. But further this you can also simplify, as T1 from 1 is M1A, and here you can write T2 is equal to M2A plus T1. T1 is M1A, so and hence you can take actually as equation 2 instead of the above one. Now free body diagram of 3. So mark M3. Here forces are F to the right and T2 to the left. As a result, it is moving with an acceleration here to the right. Now equation of motion, force is dominating, so F minus T2 is equal to M3A. Again, T2 from equation 2, if you substitute here, then you will get F is equal to M3A plus T2 you can write. So here that is M1A plus M2A plus M3A, it gives, directly I am writing M1 plus M2 plus M3 by into A. So therefore A is equal to F by, again the video may block. Yeah, see here, A is equal to F by M1 plus M2 plus M3. So this you can get by using the shortcut formula only. What is that? By using shortcut formula, A is equal to net force by total mass. Net force in the diagram is the only force is F, so you can take this as F. Total mass is, there's 3 blocks are there, sum of those masses M1 plus M2 plus M3 will give you acceleration directly. Simply you can take instead of all this. Okay, but why you have